Hello, hello. Welcome back to another Coding Notes Every Day Until I Get a Job. This is day 132, and today I'd actually like to finish or at least start the CS50 lecture finally. But yeah, I guess. Yeah, I guess last time I wanted to try that, but there is a lot of issues with Moneta. But now it's fixed. But I don't think I need to show it because it's for my own thing anyway. Says 50 lecture, save, and yeah, I already bought a notebook to write some notes down because I don't know, I guess typing it doesn't really put it in my brain, like, if that makes sense. But yeah, so we're gonna watch some CS50, gonna relearn a bunch of stuff and basically fix my logic that has been brain rotted this whole time. But yeah, we'll see how that goes. I need both my arm now, and yeah, might need to buy some monitor arm, but that's for another time. Okay, so the chat is back. Hello, hello, hello. Okay, we have all streams working, things working, and boom, let's do it. Okay, I think we can maybe make the Konoha Night very low or whatever the music background. Okay, so we don't need to do scratch or C. Let's start with array. Because that's like the, I don't think I want to start from like 0 0 scratch. So I think I want to start with week 3, the algorithm, but then the week 2 is kind of interesting. I already watched a little
Silver or
bit.
gold traces that are essentially like tiny little wires that allow zeros and ones to flow back and forth. And there's these black chips that actually store the zeros and ones.
So yeah, I already watched like, I think I skipped a little bit, so it's not entirely the whole 50 minutes, but I guess we should just continue from here.
Memory. So if we actually zoom in on one of these black chips, I'll propose that no matter how big this chip is, I bet we could come up with addresses for all of the bytes therein. So if this thing is like 1 gigabyte, 1 billion bytes, it doesn't matter how we number them, but for the sake of discussion, maybe this is the first byte, this is the second byte, this is the third byte, this is the billionth byte for gigabytes.
Well, this is
So
the wrong type of book. I
imagine
thought
if
it
we've
would
got
be like
this many bytes,
whole blocks,
we can
but
slap some
I
numbers
guess.
on them. Just like on a building in the real world,
Never
you can
mind.
slap a unique address on it, like 45 Quincy Street, Cambridge, Massachusetts, 02138, USA is where we are now. In the world of memory, let's keep it simple. 0, 1, 2, 3, and so forth. So let's actually redraw this as a grid of sorts, whereby each of these squares represents a chunk of memory. So if you were to store a char in the computer's memory, that's 1 byte. So maybe if the human were just to type in a single character, maybe it would be stored up there in the top left corner, or who knows, somewhere else.
I think we can turn off
If
the
you were to
music.
store an integer, which is 4 bytes typically, maybe it would be stored there, but they are necessarily contiguous. Can't use 1 byte here, 1 byte here, 1 byte here. For data types like integers and strings and chars, they're all going to be back to back to back. So that's 4. What about a long or a double for that matter? You might need 8 bytes. Those are all going to be contiguous here. Well, let's actually go ahead and abstract away the hardware because it's not really that interesting that there's a physical circuit board. Let's think about memory more abstractly as just like a canvas, kind of like in Photoshop, where every little dot can store some byte, some set of 8 bits. Let's zoom in here and consider what could go inside of those bytes. So for instance, how about 3 lines of code like this? Out of context, but suppose we whip up a program real quickly that allows me to calculate like my average on like 3 homework assignments or 3 quizzes or 3 exams in this class or any other. Suppose I did, so-so on the first 2. Score 1 was 72, score 2 was 73, score 3 not so good, 33. What's my average grade as of now? Well, I think we could whip this up pretty easily. For instance, let me go over to VS Code here, and let me go ahead and create a new file called, how about scores.c. And in scores.c, I'm going to go ahead and do maybe a little something like this. Include standard.io.h, int main void, and inside of main, let's do int score1 equals 72, int score2 equals 73, int score 3 equals 33, and now let's just print an average. So, and I'm going to make a comment to myself, print average, so I remember what's going on. Comments are just for the reader, not for the computer's sake. Printf, average colon, just to format it nicely. I want as many partial points as I can get, so I'm going to use a float instead of an int, \n. And then to compute the average, just like in the real world, I think I do score 1 plus score 2 plus score 3 in parentheses, all divided by 3, and then a semicolon. So let's see if this works. I'm going to go down to my terminal window and do make scores, which will run Clang for me. But I screwed up already. Let me make this bigger. I'm not sure we've seen this error before. Let me rerun it more simply. What did I do wrong here? Even though it's cryptic. Yeah, I'm back? Or just stretching? Just stretching. Yes, in there. I'm missing a parenthesis. I don't think so. Not bad instinct, but I'm not in this case. I think I'm balanced. The format is wrong. So the format code is wrong. I'm using %f, but it wants me to use %d, which technically means decimal, which is a synonym for %i for integer. But I actually, no, like I don't want it to be an integer. Like if I get partial credit, like I want to be rounding up, not down, so to speak. So there's actually a more subtle error. And remember the issue last week of truncation, whereby if you've got int plus int plus int divided by int, what do you get back? You get an int. So you don't even round properly. It truncates everything after the decimal point. So one way to solve this problem would be to say, all right, really, I want to divide by 3.0. So long as you get a floating number involved, then the math will work correctly. Or I could do what I did last week too. I can cast the 3 to a float, but frankly, it's pretty equivalent and few keystrokes fewer to just say 3.0 as my denominator. And again, to be clear, the reason for that, I don't want integer division. I want a floating point value. So if I'm getting partial credit, it's point something. That's not thrown away. All right, let's try again. Make scores, enter. Seems to work now. /scores, enter. And my average is indeed, thank you, 59 1/3. Still kind of failed, but like at least it's not 59.0 truncated down. All right, so that's one way of doing this, but what's actually now going on inside of the computer's memory? Well, here is the computer's memory, abstracted away as just squares. When I create score 1 as a variable, that's like asking the computer for 4 of these squares, call it score 1, and plop the number 72 there. When I ask for score 2, that's like getting another 4 bytes of memory, probably next to it, but not necessarily. And when I create score 3, that gives me another chunk of memory, also 4 bytes, with the number 33. Again, because there's no other variables as of yet in this program, they probably will end up back to back to back, but that's not necessarily a requirement depending on how you implement the code. Well, what is the computer really doing in the memory there? Well, it's really putting 3 patterns of bits.
How should I be able to remember this here? Because he started off with the typical data types and then the sizes of those data types in the memory. Maybe I could ask, let's just do all classic, you know. No, let's challenge to use as little as AI as possible. What is happening? Please do not have paywall, because that means I need to find a website to open those paywalls, please. Okay. Okay, this is it a bit too much? Keyboard, mouse, storage devices. Yeah, it's paywall. Never mind. How does the computer stores value in memory? I'm learning assembly and if you're wondering, okay, are we gonna start with, I don't want to start with assembly, although I think we should. There's a decimal value. No. Okay. Hello, Texo. Welcome. Hello. Welcome. Okay, you know what? Let's just
3 patterns of 30.
I still have 1 hour more of the lecture.
Again, by default, integers tend to use 4 bytes, or 4 times 8. 32 bits total. Okay, so if that's what's going on inside of the computer's memory, would seem to be correct, and indeed my
Which
math was
country?
correct. But what is
Me?
badly designed about this program?
Which country I am from? Or which country I am currently in?
Shortcomings. But what's bad? Yeah. Yeah, really well said. So if I wanted to add in more scores, like next week a 4th score, then a 5th score, then
Would
a
it be
6th score,
functions
well,
or
I can just kind of
arrays?
modify
Okay.
the code and add a line here, but then I have to add like variable here. Like it's not very well maintained. And honestly, if you kind of let your mind extrapolate, what if I've got like 10 scores or 100 scores over the course of like years of college?
Exactly.
Does it really seem like good design to have int score 45, int score 46. Like there's got to be a better way than coming up with these stupidly named variables where I just manually add a number. Wouldn't it be nice to just call all of them collectively scores and not have to create individually all of these unique names? And frankly, I don't have to call them score 1, score 2, score 3. I could have called it A, B, C, or something arbitrary like that, but that's even less clear. It would be nice to just call them all collectively one thing.
I am from Indonesia, but I'm currently studying in Germany. Hello, Taxo. Welcome from Nepal. Isn't it like midnight in Nepal?
Sequence of values back to back to back in memory. An array is a sequence of values back to back to back.
Hello, how is Nepal doing? Because a few months ago we heard
along those lines. And the syntax for creating a single variable that contains not one, but any number of values is relatively simple in C. You simply specify what type do you want the values to be, int. What do you want the name of the variable to be? Scores, plural, just for clarity. And how many integers do you want to be associated with this variable called scores? You use square brackets, which is something new now. But the square brackets indicate, hey,
Lado.
Compiler, this is an array.
Is it like a bad word in...
that will give me access
I don't know
to
what language does
back to
Nepal
back in
speak?
memory.
Nepal.
So if I want to now initialize each of these values to numbers, the syntax is pretty similar to before, but I don't have to come up with new variable names for each of them. I can instead keep using this square bracket technique as follows. To initialize the first score, I can say scores bracket 0 equals 72, semicolon. The second one is scores bracket 1. The third is scores bracket 2. They are zero indexed, so to speak. As before, we're almost always going to start counting from 0 in C and in most other languages. So 0 is the first, 1 is the second, 2 is the third. But notice these aren't separate variable names now. They're all called scores, but I am indexing into the array by jumping to a specific location. The first one, the second one, or the third one. First, middle, last, so to speak. So if I want to use this technique now, let me actually go back to VS Code here, and let me modify my version of scores as
It means love.
Aw,
thank you. Of course it means that.
Repeating myself a few times, but I am going to clean this up. I'm going to say int scores bracket 3 to give me an array of 3 values. Then I'm going to manually say scores bracket 0 equals 72. Scores bracket 1 equals 73. Scores bracket 2 equals 33, semicolon. And then down here, I have to change my formula to be scores bracket 0, scores bracket 1, scores bracket 3. So
when does it start with the looping and stuff? Does it have? Do you have
same reason as before.
like Google Slides or notes that we can take?
Make scores again. Seems to compile /score still gives me the same value, but it's a little better designed. I've got one variable now with 3 spots in it instead of 3 variables, and God forbid even more if I want more and more of these values. Well, what is now going on in the computer's memory? Well, these 3 lines of code now look fundamentally the same, 4 bytes, 4 bytes, 4 bytes, but the names that the computer is giving them is scores bracket 0, scores bracket 1, scores bracket 2, and to be clear, it's one variable, but this is saying go to the first location, location 0, go to the second location, aka location 1, go to the third location, aka location 2. It's a little confusing that everything's off by 1, but you get used to it over time. So if that's what's going on inside of the computer's memory, let's actually tinker with it further, and toward this end of making it even better ultimately, let me propose that we go back here and maybe modify this as follows. Instead of hard coding my 3 scores, 72, 73, 33, and then having to like update this code next week, and then update it in 2 weeks by adding more and more scores to it, what would be the right programming technique here to like just prompt me again and again?
Make a function.
like loop again,
Loop
right? We don't have
function,
to write all
yeah.
these lines of nearly identical code. So let me do this. Let me get rid of these 3 lines, which look like copy-paste, except for the changing number. Let's do for int I is 0, I less than 3. So I'm not going to screw up this time. Not less than or equal to, but less than 3, I plus plus. Then inside of this for loop, let's go ahead and use this syntax. Scores, bracket I, equals, let's actually ask the user now for their score rather than hard-code it at all using getInt like this. So we're using the square brackets now in a few different ways, even though the rest of the code is now the same. In this line of code, I'm declaring the variable called scores to be an array of size 3 integers. Kind of a mouthful, but that's all that's going on there. When I use the array later, I don't have to say int ever again. That was just to tell the computer once what types of values do I want to put in here. Hereafter, I can just say scores bracket I. Well, what is I? Well, on the first iteration of this loop, it's going to be 0, and then 1, and then 2. Like magically, it's going to plug into those square brackets exactly the number I want. 0, 1, 2, on up. GetInt is going to be called 1, 2, 3, or more times based on however many times I loop, so I don't have to type 72, 73, or 33 in my code at all. Now, the code is still imperfect. I'm still kind of cheating that I've got the 3 here, I've got 3 of these here, I've got the 3 here, the 3 here. This is still poorly designed, but it's
You know
better
VS
poorly
Code,
designed in the
yes.
sense that I've got this
I
magic
still
number
use VS
3
Code
everywhere that I am going to mess up
sometimes.
at some point. If I change it to a 4, I bet you
I'm
I'm going to
just
miss one of those locations.
trying to
So we should probably
relearn the
improve that
basics
as well.
again
Well,
from
let me go ahead and just confirm that I didn't make
Professor
things worse. Make
Milan
scores.
here.
I did. What did I do wrong here? Error. Call to undeclared function getInt.
Because you need to include something
Yeah,
to
I
get
didn't
the
include
getInt.
cs50.h.
Yeah.
That's why the compiler just doesn't know what a getInt even is. So that's an easy fix. Let me go ahead and type that in here. Clear my terminal. Rerun make scores. OK, now we're back in business. /scores. Now I'll type them in when prompted by getInt. 72, 73, 33. And I'm still getting the math correctly. But I can do a little better. So let me.
I'd like to write this down. I think that's really fun for like the memory stuff. Boolean is 1 byte. Boolean, integer, long, of course. Since he's using C, it would be that. But would it be the same in other languages as well? Or doesn't matter? Because we have gigabytes of RAMs anyways. That's way too expensive to buy right now. String is unknown. Char is 1 byte. Boolean is also 1 byte. Integer is 4 bytes. Long is 8 bytes. Float is 4 bytes. And char double is 8 bytes as well. At least in C. No, I try to make
In my terminal window,
a
I'm getting
website
this magic
and
number
web
3.
application.
How can I do
But
this? Well, I could do something like this.
I'm learning this to kind of
capital N,
go back to
equals
basic
3
and
for a
relearning
number
everything
is not
because
changing, but actually there's a technique.
I
If
really,
you
really
to
don't
tell
want to
the
be
computer,
dumb because
don't even let me change this
I
number.
did an interview and I
What can
failed.
I write
So
on
I
line
kind of
6
want to
for int?
be
Const.
better
We haven't
at
used
this.
it much, but this is just a way of protecting you from
So yeah,
yourself
basically I
or
just want
protecting
to
your code from some dumb colleague who goes in and tries to change a number that they are not supposed to. So const int n equals 3 means this variable shall be forever the value 3. What can I then do with this? Well, I'm going to change the 3 here to n, the 3 here to n, and down here it's kind of a step backwards. I don't want to do n just yet, but I can cast this to a float to make sure that that 3 is treated as though it's 3.0. Now, I capitalized n just by convention. Generally, when you use constants, humans tend to like capitals. Why? Because it just jumps out to the reader, wait a minute, like this is capitalized for some reason. That usually means it's meant to be a constant, just as a little
Hello,
visual
we
aid.
have
This is
Aziz
still
back
imperfect
and
because I'm
Taxo.
still
Welcome.
assuming that n is always going to be 3, but one problem at a time.
Hello,
Let me open my
hello.
terminal, make scores, /scores, 72, 73, 33. Code still seems to be behaving correctly, except for, notice this time we're seeing a bit of an artifact. Now suddenly I lost a 10, 100,000, 10,000, 1 millionth of a point. So the rounding's a little different, but that's because fundamentally when
Sure,
dealing with
why not?
floats, they are going to be imprecise. Maybe not very imprecise, but slightly imprecise. Thus far, we were getting an additional 3 there, not a 2. That's just a side effect per last week's discussion. Well, let me go ahead and do this. Instead of typing this one out myself, let me go ahead and grab sort of from the oven already cooked a program called Scores version 5, which I wrote in advance, which now has everything. So this is a lot on the screen all at once, but let's focus on what's similar. I'm including cs50.h and standard.io.h. I'm declaring a const. Notice, though, that I've put it at the top of my file instead of inside of main, and that's OK. It is sometimes OK and a good idea to put your constants outside of functions so that if I do want to change it somewhere, it's obvious where to change it. It's not buried in some function. It's at the very top of the file where it's more obvious to the reader. Notice now I've introduced a function called average, more on that in a moment, because the problem I still had was even though I had 3, 3, 3 in a variable, I was still manually adding scores 0, scores 1, scores 2. What about scores 3, 4, 5, 6 as the program grows? Well, how am I solving this? Well, notice this. In main now, I'm giving myself access to n scores. So whatever n is, make the array big enough. And this is a cool technique with arrays. If you don't know when you write the code what the size is, just use a variable. And the computer will give you an array of that many spots. The for loop is exactly the same here. Exactly the same here. I'm just prompting the user again and again for each of their scores. The only thing I've changed now.
You can. I have a.
Instead of
We have a like a Discord channel. You can share to the. There is a channel for showing your projects if you want. Let me know if the link is still valid or is it already expired. It's in the description, hopefully. I think I already put it there, but let me know if that works or not.
Out the average of score 0 plus scores 1 plus scores 2 divided by 3, I'm actually asking a helper function, so to speak, another function that I wrote called average that takes 2 values. One is n, because it's got to know how many values to average, what's the denominator, and then the array itself. And this is the only new piece of syntax now with respect to arrays is how I'm passing this in. Let's focus on just the math for a moment. How do I calculate an average when I don't know in advance how many values there are, so I can't just do this plus this plus this, all divided by 3? Well, let's create a variable called sum. Let's then iterate over the length of that array. Let's use some of last week's syntax to add to that sum the value at location I, location I, location I, as I goes from 0 to 1 to 2 on up. And then lastly, how do you calculate the average? Well, whatever that sum is, divided by the length of the array, casted again to a floating point value. So the only thing here is a recollection from sort of grade school that to calculate the average, you just add all of the numbers in the numerator and divide once by the denominator. So I've used some C code with a variable and a for loop to do just that. The only weird thing I'll call out here is this. Notice how I wrote the average function. It's called average. It returns a float, which we haven't seen before, but it stands to reason. If we can return ints, and if we return nothing, like void, I could probably return a float, and that's correct. This is the output of this function. That is why I can return a value. But this is weird. Not only does average take 2 arguments, one of those arguments, as of today, is now an array. So I could call these arguments anything I want, a, b, x, y, but I'm calling them more usefully the length of the array, and then the name I want to give this array. But I could call it anything. I could call it numbers, but I called it array for the sake in class of making super explicit what an array is. But this is the weirdness. When a function takes as input someone else's array, you don't have to know in advance what the size is, so you just say open bracket, close bracket, and leave it at that. But you need to make sure that that caller, the function who created the array, also tells you with a second argument how big it is. This is not true in Python, this is not true in JavaScript and certain other languages that some of you might be familiar with, but in C, if you pass an array as input, you don't have to, the function doesn't have to know how big it is, but you have to tell it how big it is by giving it a second argument. And that's it for this use of square brackets. We've used it to create the array, to access or index into the array, and now to pass the array. So square brackets almost always are going to hint there's an array going on here. I suppose we should run this to be sure that I didn't screw it up. So make, let's do this.
I think we have.
Copy.
Okay, let me see. I think if we go into WSL, it's already have some C compiler, so we can give it a try as well. But my new Vim is broken, so I don't know if that's usable or not. Let's see. I think I have some C code here. Like I was playing around with it sometimes ago. Okay, it's still loading. Nope, it's not loading.
2 scores 5. So we haven't showed you this yet, but if I have a file secretly called scores5.c and I want to rename it to scores.c, I can use the cp command for copy for short. It's going to prompt me overwrite scores.c. Yes. And so now if I open what was always called scores.c, I now have exactly the same file as we walked through a moment ago. So let's run this now. Make scores, /scores, 72, 73, 33, and we still get the same correct average. But now the code is arguably not only correct, it's better designed, even though things kind of escalated quickly, because to make this code better designed, I needed to generalize it to handle not 3, but ultimately any number of exams or scores.
Let me try. I think, yeah, I have to learn C, so we can do learn C, and then we can go to Vim, although it's probably broken. Yeah, there we go. Okay, I'm definitely gonna need to fix it somehow. Okay, never mind. That's not what I want. To be honest, I forgot. What is like the command for it? Is it control? Is it control B? No. Okay. Damn it, I forgot. Is it shift N? Control N? Yes, it's control N. Okay. What is this? Okay, I have no idea. What was that? So it's control N. Oh, I did this. Okay. Maybe we can try something.
By changing the 3 to a 4 or a 5 or 100 or anything else. And heck, if we really want, we could ask the user how many scores do you have already by calling get in one more time and then avoid the constant itself. Whew. Okay, that was a lot just to calculate a very bad score. Questions? Yes?
Check.
A really good question. What happens if you try to access a point in the array that hasn't been given a value yet? We will see that actually soon. You can go there, but you don't know what you're going to expect. So just to be a little dramatic, why don't we go ahead and have some delicious animal crackers, take a 10-minute break, and when we come back, we'll start building on these examples.
They give food in Harvard? Damn.
Now that we have this new tool in our toolkit of arrays, let's see how we can sort of take it out for a spin and sort of rethink and also solve different types of problems, starting with a super simple message of hi, which is where we really began over the past couple of weeks too. So suppose I wrote some code and an actual program soon that just stores 3 chars, and I'll call them simply C1, C2, C3, initializing them to H, I, exclamation point, which
character is
not coincidentally
1 byte.
Is exactly the numbers we've been playing with, 72, 73, 33, recall, from our so-called ASCII charts from weeks past. So what's going on with code like this? Well, let's go ahead and try it out. Let me open up a new file called howabouthi.c, and in VS Code, I'm going to quickly do include standard.io.h, int, main, void, and then inside of main, let's give exactly those 3 lines, so char C1 equals quote-unquote H, char C2 equals quote-unquote I, char C3 equals quote-unquote exclamation point. And just to be clear, why am I using single quotes instead of double?
Preference?
So it's a character, not a string. So strings are individual
I remember it now. Okay, character using only 1. Single quotes. Really? I forgot that. Okay, damn.
Are single quoted. All right. So with that said, let's actually just poke around these variables. So let me go ahead and use printf and print out 3 things. 3 placeholders, %c, 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 \n, and let's plug in the value of each of those variables, C1, C2, C3, just to see what's going on. Well, this one won't be all that enlightening, but if I do make hi, /hi, I should see literally HI exclamation point. But I'm not printing it as a string. I'm printing it as char, 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 back from left to right.
I kind of want to play around. Okay, let's do this. How to compile C in WSL? I think we still have. Running written C is not okay. That's not what I want. Okay. Okay, fuck it. I know I don't want to use AI, but I guess this is just, it's gonna be faster a little bit, even though sometimes it doesn't really show. Command to compile and run C code in WSL Ubuntu. GCC/program if one warning is enabled. What is that? If GCC is not, so I think I already have GCC, so it's the Marcus or simple makefile or debug. Okay, makefile I think is gonna be similar to what the professor did, just a single file, and it's gonna compile and run it. But GCC program -o. Okay, so what we can do is good. Okay, so what we can do is we can create r.c, include, okay, stdio.h, Wow, chill out, man. Okay, I do not want to have AI directly, so calm down. So we need int main void c equals to, okay, c equals to, yo, okay, at least it's the LSPs are fast. Char C3. Okay, yeah, it's using the same training data. Nice. But no, I wanna just use good old basic typing, you know? Okay. And then we can do, oh shit, wrong one. Oops. Then we can do GCC, oh shit. GCC, what's the command again? GCC, char C dash O, let's name it char. Oh, sorry, that's 0, char. And then we have char, and then if you want to run it, then just do char. Hi, cool. Okay, I know, it's never mind, sorry.
All right, so can I maybe improve this a little bit? Well, let me go ahead and tinker like this. If I actually want to see the numbers that the computer is storing, let me first kind of add some spaces here for clarity. And let me add some spaces here for clarity. And let me change the placeholders from C to I. Because it turns out that if characters are just numbers, per our discussion of ASCII and then more broadly Unicode, what's really stopping me from just telling the computer, treat this sequence of bits not as a char anymore, but as the integer that it actually is. So we can use printf with %i instead to do exactly that. So let me rerun make high, /high, and what should I see now when I hit enter?
The memory number?
Probably 72, 73, 33, which we keep using. And indeed, that's all that's going on.
Is it the ASCII character?
So to speak, of these three characters. In fact, if we take a look at this code now in the context of the computer's memory, a char, recall, is 1 byte by definition. So we need 3 such bytes for 3 chars. So that might end up being I exclamation point here, or who knows, maybe elsewhere in memory, with those 3 variable names now in describing those 3 locations. Well, once I've got that in place, what's really going on underneath the hood? Well, obviously, it's actually storing 72, 73, 33. And if we really go down lower level to where we began week 0, technically what's inside of the computer's memory is these 3 patterns of 0s and 1s. But again, who cares about these 0s and 1s? But they are there. But it's easier to think about them as numbers, or in the context of actual words, characters instead. So what is a string? Well, we introduced a string last week as being a sequence of characters.
Sequence of character.
It turns out that we actually really know more so now what a string is. So for instance, here is an
example a sequence of character
called s and setting it equal to the value of high. Let's actually put this into some code. Let me go back over to VS Code in high.c, and let me just tweak this code by really throwing away all of these lines. Let's do string s equals quote unquote, in double quotes now, high exclamation point, and then print out %s \n and print out s itself. And just so I have access to it, more on this another time though, well, odds are we're going to see 2 chunks of memory in use, s and t respectively. Maybe s ends up here, which is the whole thing here. Technically, this is s bracket 0, 1, 2, 3, but who really? So we can actually see this. If this is what's actually going on underneath the hood, we can actually see the fact that this is there. Let me go back to VS Code here. And let's just kind of get a little curious. Instead of printing out 3 of these things, let's go ahead and do this. Let's print out %i, %i as before. And this is no different from earlier. Make high, /high. There are those 3 numbers. But let's kind of get curious and print out one more placeholder, %i, and print out s bracket 3, which I'm assuming will exist because, as indicated, a string always gives you 1 extra byte for that special terminating character. Make high, /high, voila, like there is the 0. Unbeknownst to us last week and unbeknownst to us before break, it's always been there with any string underneath the hood. The variable keeps track of where the string begins, but zeros indicate where the string ends. Questions on this technique or this implementation detail? Yeah. What would happen if you went to the next? Good question. And honestly, there's nothing really stopping us. So let's try going one more location. So S bracket 4. Let me go ahead and do make high dot slash high. 37 comes next, whatever that is. If we do one more, percent I, S bracket 5. Let's do make high.
That's just the
high,
memory? Would that be just the memory?
So these are actually unpredictable and are actually representative of those same kinds of garbage values that I alluded to earlier that don't really belong to us. Like I really shouldn't be poking around places where I haven't asked for the computer to give me memory. But odds are those are sort of evidence of other values in this program, or maybe remnants of the memory having been used prior. But the only one we can trust will. So what is this thing called? Well, it's conventionally, this thing is called null. So N-U-L, single L. We'll see another version of null that's spelled a little differently, and we've actually seen it before, even though we kind of waved our hands at it. Here was the ASCII chart from week 0, in fact, and we focused on HI exclamation point, but here's the first column, and notice location 0 in the ASCII chart has always been what humans call NUL, or null, which is just a special sentinel character, a terminating character that says string ends there. All right, well, what if we have multiple strings? For instance, like one string S called high with a value of high, and one string T with a value of bi. Let's actually play a little with that and see where things end up in memory. So let me go back to VS Code. Let me get rid of this long printf, and let me give myself another one, string T equals bi exclamation point, and I'll print out both of these. Printf, quote unquote, percent S backslash N, comma S, and then printf, percent S backslash N, comma T, semicolon, and now make high dot slash high, and we'll see, as you would expect, just high and bi on the screen. What's going on inside of the computer's memory, though? Well, odds are we're going to see two chunks of memory in use, S and T respectively. Maybe S ends up here, which is the whole thing here. Technically, this is S bracket 0, 1, 2, 3, but who really cares at this point? It's just a string called S storing this value, and though this is up to the computer and the context in we write the code, odds are bi will end up right next to it in memory. It's too big to fit on the screen, so there's still another character here, but it's indeed here. So even though you and I only ever write high exclamation point or bi exclamation point, the backslash 0, the null character, ends up being added automatically for free. And fun fact, this is what the double quotes are implying. When you use double quotes, that's a visual cue to the language. Oh, this is a string. Let me terminate it with backslash 0. You do not want a backslash 0 for a single char, because single would mean one character. So single quotes distinguish that for the computer as well. All right, so now that we know this, we can actually sort of solve other problems as well. In fact, let me go ahead and do this. Let me go ahead and syntactically play around here. So if I know that I have two variables here, let me sort of draw some inspiration from the scores example. If I have a whole bunch of strings, I probably don't want to call it like ST, UV, and so forth. Let's just give myself one variable called one variable of type string called words. Let's give me two of them for the sake of discussion. And then let's have the first word, so words bracket 0 equal quote unquote high. Let's have the second word, words bracket 1 equal quote unquote bi. So just like I did with the scores, let's just consolidate all of these arbitrary variable names into just one. That's a little more descriptive, like scores, or in this case, words. How do I now print these? Well, instead of printing S and T, I can print words bracket 0, and I can print words bracket 1. And if I go down to my terminal, make high again, dot slash high, still says the exact same thing. But here's where things get kind of interesting. You can compose these ideas in different ways. Like, this is not something that's useful, but it does speak to the fact that there's no magic. Like, now that you have the square bracket notation, you can start poking around wherever you want, for better or for worse. So for instance, suppose I want to print out the three-letter word high. Well, I could change percent S to be percent C, percent C, percent C for HI exclamation point. But wait a minute,
That
how do
would
I print
work,
out
no?
characters? Well, this is kind of a neat feature. If words is the array, and words bracket 0 is the first string in that array, well, what is a string? It's just an array itself. So if you want to go into the first character of the first word, you can actually do this syntax. Use brackets twice. The first set of brackets says, what word do you want? The second set of brackets says, what character do you want? Because again, this is an array of strings, aka
Arrays
array
of arrays, characters.
arrays. So let's
Of
do
characters.
words bracket 0 bracket 1, word 0 bracket 2, and then down here, I know this is a 4-letter word, so again, this doesn't really solve a problem, it just demonstrates what's going on. Here's a 4-letter word. Let's change this to words bracket 1, location 0, words bracket 1, location 1, words bracket 1, location 2, words bracket 1, location 3. So again, not something that's really compelling to use, but it does demonstrate that there's no magic. All that's happening is percent S is saying, go print a bunch of characters until you see the backslash 0. Percent C is letting me manipulate these things manually. So make high, dot slash high, exact same thing as before, by just building on the assumption that these strings are really just arrays. Okay, so how do we actually leverage this idea and sort of figure out dynamically how long these strings are? Because I bet anytime we want to start iterating over the length of text, maybe to determine like the reading level of a chunk of text, we're going to have to be able to read the thing from left to right and stop when the sentence or the paragraph actually ends. So how might we do this? Well, let me actually go back over to VS Code. Let's create a new file called length, and let's write a program that figures out the length of a string for us. So length.c shall be the name of this file. Let's go ahead and include cs50.h at the top. Let's include standard.io.h at the top, int main void, and then inside of main, well, let's do this. Let's ask the user for their name, string name equals get string, and then prompt them for their name with name colon quote unquote. Then let's go ahead and figure out the length of this string. So how can I figure out the length? Well, bunches of ways, but loops come to mind if I want to iterate from left to right. So let me propose that we first initialize any variable to 0. I'll call it n for number, but I could call it length or count or whatever. Then let's do a for loop. Or no, let's do a while loop actually, like this. While the name array at location n does not equal the null character, go ahead and increment n. And then at the very bottom here, let's just print it out, printf of %i \n n. All right, so there's a bunch going on here, but it's a relatively simple idea. What do we have? So we're prompting the user on line 6 for their name. Pretty straightforward per last week. Line 8, we're just saying start a variable at 0. So like all fingers are down or the stress ball bowl is empty. This is the only line that's a little weird to see for the first time, but it's just doing this. Line 9 is saying while it is the case that the name string at this location does not equal the null character, increment n. So it's like using a finger and pointing at the string from left to right, asking itself, is this null, is this null, is this null? And if it is not null, then it's going to increment n. So if the first letter is h, at location 0, well, h is not equal to the null character, so n gets incremented once. So the expression hi has at least a length of 1. I does not equal the null character, so n is going to get incremented again. The length is now at least 2. Exclamation point does not equal null character. N is now 3. But what comes after h, I, exclamation point? The null character.
The null character.
So the character at location 3, name bracket 3, which is the 4th total location, because we started counting at 0, is the null character. This does not get incremented anymore. I've only got 3 fingers still held up. We're going to see the value 3. So this is a very mechanical, kind of clunky, but very correct way of figuring out dynamically the length of a string by just looking, and figuring out where it is. How does printf then know when to stop printing characters on the screen when you just hand it the name of a variable? It is literally doing the same thing. It is looking at your string left to right and checking, is this null, is this null, is this null? And as soon as it is null, it stops printing words on the screen. It's been doing this for us since last week. So if I open my terminal window now, do make length, enter, /length, type in a name like David, enter, and I do get back the number 5. Not 6, because I'm not including the null character. I'm stopping once I hit it, and therefore I get 5. Syntax is a lot, but any questions on this here? All right, well, let's make one tweak and then make it even simpler. So in my code here, wouldn't it be nice if I could just call a function that figures this out for me? So for instance, suppose I want to get the length of the name. Well, let's just give myself a variable called int length, set it equal to the return value of a magical function that doesn't yet exist called string length, and pass in the name to that function, and then go ahead and print out with printf exactly that length with %i, comma length. So wouldn't it be nice if a string length function exists? Well, it's not that hard to create one. If I have a function called string length that returns the length of a string, I want this function to return an int, so that's its output, or return type. The name is going to be, of course, string length. What's the input to this function going to be? Well, it expects a string as input, and I can call it anything, so I'll keep it simple. I'll call it s for string. And then inside of this function, honestly, I think I can kind of copy-paste that code from before. I just need to change name to s, and instead of printing n, what do I want to do at the very last line here?
Return.
Yeah, so return s, hand it back to whoever is using this function so that it gets passed from right to left, stored in this variable, and then printed. There's one thing I have to do, again, it's kind of silly, but copy-paste the prototype at the top of the file so that the compiler knows about it. But I think now I've created my own string length function that can just figure this out for me. And as before with Scratch, sort of out of sight, out of mind, I never again need to implement a string length function if I've already done it once. But let's not be dramatic. Let's just undelete all of these blank lines. Let's now compile this code. So make length again. I messed up. What did, I don't want to return s, I screwed up. I want to return n, which is the number, s is the string. So that's what it's saying here, and we'll come back to in a couple of weeks what these words like pointer and conversion mean. Make length, there we go, /length, DAVID, I still get 5. Well, wouldn't it be nice if like someone had solved this problem for us already?
Yes,
It turns out there is. So
someone have.
There are some standard libraries that come with C, not just CS50, not just standard IO, not just the math library. There's actually a string library that's got a bunch of string-related functions in it that are super helpful. In fact, in the manual pages or man pages for the string library at a URL like this, which is CS50's version, you'll see exactly an option called the strlen function, S-T-R-L-E-N for short. There's the documentation on the screen, and sure enough, there exists a function called
If I import
strlen
CS50, which I do not have, that wouldn't work, right? Because the .h has to be somewhere in.
As well as its prototype.
And okay,
I do
never
need
mind.
to include one more header file, so string.h, but instead of calling string length, I can call strlen,
Strlen.
and now my program's done. So here, this is sort of evidence of like why we stand on the shoulders of programmers before us. Like someone else already solved this problem. It's sort of intellectually interesting to understand how they solved it, but why bother reinventing the wheel again and again when you can use a library function to do exactly that? So this version of the code, I think, make length /length
To uppercase. Okay, in JavaScript and in Python, there's already like a method, right? So
a dozen or more.
It would be so easy to.
For a moment.
The program looks at each character.
On any of this. Questions? No. All right, so let's do a different sort of problem. But
okay, this ASCII thing, I'm gonna need to reread about it.
The strlen function in the string library. There's another oddly named library called the C-type library, which is related to C types. So converting from one thing to another or detecting things. So in the C-type library, whose documentation is here, you'll actually see a whole bunch of functions. So if I go here, you'll see things like isAlNum. It checks whether a character is alphanumeric. Is_alpha, check whether a character is alphabetical. IsDigit, check whether a character is a digit. Is_space, check whether a character is white space, and so forth. To upper, to lower, to convert a char to lowercase, to uppercase. There's so many functions that someone else wrote that actually seem at a glance pretty useful. But how might those kinds of things be implemented? Well, here's that same ASCII chart as before, and notice this kind of curiosity. Here are the start of the uppercase letters. Here are the start of the lowercase letters. And just take a look at like A. We know from week 0 that A is 65, and apparently lowercase a is 97. Quick mental math, how far apart are those numbers?
32.
7 minus 65. That's right, 32. So they're 32 apart, but notice the pattern. How far apart are 98 and 66? 99 and 67, and so forth. They're all 32 apart. And this is actually wonderful for the real geeks in the room. Like, you can just change one bit out of 8 and turn a number from uppercase to lowercase and back. But for the rest of us, notice that 32 is the constant here that explains how you get from uppercase to lowercase and back. Well, we could leverage this and implement our own function that somehow plays around with the cases of letters. So in fact, let me go back to VS Code here, and let's create a new program this time called string.c, just to play around. And in string.c, I'm going to go ahead and include my same header file, so cs50.h, and in standard io.h, and I'm going to use string.h, and then in int main void, I'm going to go ahead and do this. Let's prompt the user for a string s by using getString, and just ask them for input, whatever that input actually is. Let me just preemptively say printf, quote unquote, output, and let me just go ahead and, whoops, close quote, close parenthesis, semicolon. And now, what I want to do is convert the user's input. Actually, for now, let's do it simple. Let's just print the exact same thing that the human types in. So we're going to keep it simple just to make sure we have the framework for a program good to go. So for int I equals 0, I is less than strlen s. Let's go ahead and do I++. And then inside of here, let's go ahead and just print out that character. So print out %c backslash, no, let's no backslash n, %c quote unquote, s bracket I. So I think this code here will print out the ith character of s from 0 to 1 to 2, for however long it actually is. And at the very end of this program, let's go ahead and print out just a single backslash n. So this doesn't do anything that interesting yet, but let me go ahead now and run make string. I messed up because I'm typing too fast. This semicolon goes on the outside. Let me do make string, /string, and I'll type in DAVID, and I get the exact same output. So not all that interesting. But before we start playing around with uppercase and lowercase, let's actually kind of clean this up slightly. This program is correct if my goal in life is to just print the exact same thing as output as I was provided with input. But it's arguably not well designed yet for a very subtle reason, even though I am very cleverly practicing what I preached a moment ago using the strlen function from the string library. Now this is super subtle, but on line 9, recall how a for loop works. Like you initialize I to 0, then you check the condition, then you do something, then you increment, then you check the condition, you do something, you increment, then you check the condition, you do something, and you increment. What might rub you the wrong way design-wise about the story I just told, given that strlen is involved in that decision-making? Yeah? Perfect, really good intuition. Like the length of s is not changing, so why am I wasting everyone's time by calling the Stirling function again and again and again? I is changing, so that part is correct, but why am I calling this function? And notice, because I have written Stirling parenthesis s, it will call the function again and again and again. It's not going to very intelligent and be like, oh, well, it hasn't changed necessarily, let me just do that for you, unless you have a compiler that has a feature like that enabled. But at a glance, this just seems very inefficient. So how can I improve this? Well, I can do this in a couple of different ways. Let me go back to the code here. Let me grab Stirling of s, and let me do this, like int length equals Stirling of s, and then I could do this. So this is arguably marginally better because I'm calling Stirling once, storing the return value in a variable, and then using it again and again. Now that's fine, that's correct, that is better designed, but this is such a common paradigm. There's another way to do this. Instead of doing Stirling of s inside of the condition, you can instead do this. You can declare a second variable like length, or heck, I'll keep it simple, n, set it equal to the string length of s, and then within your for loop, you can do the comparison by having initialized not one, but two variables at a time, so long as those variables are both the same type. Now I'm declaring two integers at once, but the first part here, before the first semicolon, is only executed once, because that's the initialization. So again, subtle, but it sort of speaks to efficiency, because I'm not calling the darn function again and again when the string s is never actually changing in length. So subtle, but arguably better designed. Now with that said, can we go and actually use this knowledge of the ASCII chart? Can we use this technique of optimizing with Stirling to sort of combine things and start changing things to and from uppercase and lowercase? Well, let's try this. Let me go ahead and open up a new file called uppercase.c. And in uppercase.c, let's go ahead and use those same files, include cs50.h, include standardio.h, include string.h, and now in int main void, inside of main, let's go ahead and do the same kinds of things, but a little bit differently. String s equals get string, and let's ask the user for input. We'll call it before. So what's the string before we do anything to it? Now let's go ahead and proactively print out the word after, just so that we can compare it. And I'm going to very cleverly use two spaces just because before is longer than after, but I want them to line up perfectly above each other. So I'm adding two spaces there just for aesthetics. Now let's do this. Let's iterate over the characters of s and check. If it is lowercase, let's turn it to uppercase. Otherwise, let's not touch it at all. So how can I express that? For int I is 0, I less than the string length of s, I plus plus, and then in here. But wait a minute, let me learn from what I just said. Let me avoid calling Stirling again and again and again. Let's just call it n equals Stirling of s, and then compare I against n. N's not changing, I is changing, so that condition is now handling the logic I want. Inside of the for loop now, I have to ask a question. Is the current character, the ith character of s, lowercase? If so, change it to uppercase. Now that's kind of a mouthful, but I can kind of use last week's building blocks and this week's understanding of arrays to express exactly that. So if it is the case that s bracket I, so the ith character in s, is greater than or equal to lowercase a, and s bracket I is less than or equal to quote unquote z, then I want to go ahead and change s bracket I to uppercase. I don't know how yet, so I'm just putting a comment, putting in pseudocode. Else, if it's not lowercase, then just print s bracket I. Now let me go back to our little cheat sheet here. So we only have the beginnings of it highlighted at the moment, but we know that the difference here is 32. But more interestingly, we know that that lowercase starts at 97, and if I look in the shaded part, it goes to 122. So technically, I could actually do this arithmetically with numbers, and I could go in here and say, is greater than or equal to 97 and less than or equal to 122. That's fine, but honestly, because we know from the previous example, a char is just an int is just a char, and you can format them however you want. You can also manipulate them mathematically however you want. So it's arguably better design and clearer to you, clearer to the TF, clearer to the reader, the colleague, that, oh, you're comparing the ASCII values, not some random number that I don't remember from class years ago. So greater than or equal to lowercase a, less than or equal to lowercase z express is exactly what we want. So I'm going to pluck off the easy one first. How do I just print s? Well, I do printf %c, comma, s bracket I. That means just spit it out unchanged. It's not lowercase, so there's no change to it. Let's just spit it out, whether it's already uppercase or maybe it's punctuation or a number, whatever. Now this part is the last part. How do I go ahead and change a character from lowercase to uppercase? Well, I know minimally I'm going to want to print some character, so let's just proactively do %c as my placeholder. I kind of want to print s bracket I, but I want to change s bracket I to uppercase. What could I do mathematically to a lowercase letter to make it uppercase, according to the cheat sheet? Yeah, just subtract 32. So subtract 32 here. And now if let's add one final flourish. Let's just add a \n, just so the cursor finally at the very end of all this is at the bottom of the prompt. Let me go ahead and open my terminal, make uppercase, enter. Okay, I did screw up, did it again, going too fast, semicolon on line 14. Let me clear my terminal, rerun make uppercase, good, /uppercase, DAVID with one capital letter, the rest lowercase, enter, and voila, now we've uppercased everything, just by understanding the underlying implementation details of what's going on. Honestly, if you don't remember 32, we can even abstract this away. Like, whatever the distance is between capital A and lowercase a, like, that's actually what I want to subtract. Oh, I could do B or C or Z or whatever. 32 is fine, but it's arguably better to do little a minus big A, because then you know it's going to be dynamic between the two, even if you forgot from class what the actual difference of 32 is. All right, but this is a little silly that I'm doing all of this work just to change things to uppercase and check for lowercase. How can I make this a little better? Well, turns out that C-type library is actually our friend here. Let me go back into this code here. Let me include my C-type library. And it's not necessary, but I tend to alphabetize things just because then at a glance I can see what header files am I actually using, and I'll know if something is missing. Let me go into my code here, and you know what? Instead of doing all of this, it turns out that in the C-type library, there was a function called toUpper. And if I read the documentation of toUpper, it essentially takes as input, per its prototype in our own documentation down here, a char, call it C, and it returns the uppercase version thereof. It technically returns an integer, but who cares? We know that this is functionally equivalent to the same thing. So let me go back to my code, and honestly, because I have now included ctype.h at the top, I can just say toUpper of s bracket I. Let me open my terminal. Let me rerun make uppercase, /uppercase, /uppercase, DAVID, and now it's still the same. But even this is kind of silly, because if I read the documentation for the toUpper function more clearly, it actually says that it will handle this conditional decision of whether the thing is already uppercase or not, or whether it's lowercase or not. So I can actually change all of this messiness into just a single line of code in my loop, printf, quote unquote, %c, comma, toUpper s bracket I. Now, semicolon at the end. Let me reopen my terminal window. Make uppercase, /uppercase, DAVID yet again. That too works. So again, like.
Okay, interesting. And he's just gonna keep iterating until it's the good one. I think I'm just gonna skip into the command line arguments.
So how do we actually write code that accesses words at the command line? Because thus far, we have not written any code, any programs that can do that. But make can, and Clang can, and other programs can as well. So how do we make our own? Well, up until now, this has been how we've implemented main. We've just been asking you to take on faith that it returns.
The thing is, I don't have the CS50 in the WSL, so how can we use it?
I've been literally typing this for every program, as did you, presumably for problem set 1. Well, it turns out that you can actually change the void in main to be something else if you want your program to accept command line arguments, words at the prompt when you run your own code. And you can change this void, it's a bit of a mouthful, to be this whole thing instead. Now, it's long at a glance, but what is it? It's 2 arguments. One is an int, one is a string, technically an array of strings. So this is why we introduced that syntax earlier. When you have an array being passed into a function, you just use square brackets and no number inside. So what this implies is that main
arguments that are passed to your program at the command line. So command line arguments, you can use those arguments in your programs. Okay, notice that this is hello to the user. Still, would it be nice to be able to make an argument? So what we need is, let's make a comparison. Normal. It's just int main void. God damn it, I'm writing code on paper just like during exam. It's been over a year, I think, or more since I did that. What's your name? And then printf that normal, but then we have the command line. It's going to be int main, and we have int argc and the string of argv, which is the array. Okay, nice.
And can, if you want, take an integer and an array of strings. Now, technically, you can call these things anything you want, A, B.
Is there like a get string? It's like a C library, C std to get input from user. Yeah, I don't know, man. C standard library. Sorry, I know I don't really like it. Okay. Is there which sees cdlib to get user input? No, it's fine. The stdio, and then we can use get strings. What's the difference between formatted input printf and then we have scanf? What's the difference between scanf and string save? fget save string. Okay, because okay, you have the size of, which is like the okay, other use of headers for input depending on use basic input scanf. Let's use scanf. Let's try. But to make the command line argument one.
XY. The convention, though, is to call it argc and argv, where argc means argument count, how many command line arguments have been provided, and argv stands for argument vector. A vector is often another word for an array, although there are subtle differences, but in this context, it just means array. Argument vector is an array of all of the words that the human typed at the command line. So how can we use this technique? Well, let's go ahead and do something like this. Let me go back into VS Code, and let's go ahead and create a program called greet.c. So in greet.c, let's write a program that just greets the user, but instead of using getString, let's just ask them for their name at the command line so they can type it all at once, hit enter, and be done with it. They don't have to wait and be prompted and then hit enter. So let's go ahead and include cs50.h. Let's go ahead and include standard IO.
Let's try. It's probably gonna be the same as the other one, but it's fine. Let's do greet.c. It's probably gonna guess what I want to make anyways. Int main. So we have int argc, and then we're going to have string, right? String argv. Shoot, I forgot we need. I don't think we have CS50, no? String.h, right? Wait, string.h? Really? Oh, wait, what? Huh. I don't type string. How? Oh, I practically already know this, but how come it? You know, let's see how.
.h int main.
Why is it string? I forgot. Why is it string not? Is it because I forgot? To be honest, I forgot. Unknown type string is. Wait, so wait, what? How is the professor able to get using a string?
Just to compare and contrast what we did last week in this.
Yes, CS50 have string type. Okay, never mind.
Equals get string, prompt the user for what's your name question mark space semicolon, and then printf.
That's why. Yeah.
Placeholder \n comma answer. So this is week 1 stuff now, and we saw this same snippet at the start of today. Make greet /greet. I am prompted for David, and now I am greeted hello David. So that's the old way of doing it. What is now the new way using this prototype for main instead, using the signal?
So how would we do it without having that? Should we just use so let me ask, how are we doing this? How can we do this with that? Oh, okay, so that's why. So it's just making it into a char. So if if argument C equals to 2, which is the number of... Okay. Is it because it have... Yeah, no, wait, let me ask the professor how to do it.
Signature, which is essentially synonymous, which means now what if main takes 2 inputs and still returns 1 output. Let me go ahead and in my second incarnation here, let's tweak this as follows. Let's get rid of all of this. Let's change the void to be int argc, comma, string argv, open bracket, close bracket, to make clear it's an array, not a single string. It's an array of strings. And then inside of this function, let's do this. Printf, quote unquote, hello, comma, placeholder, \n, like always. But what do I want to print? Well, if argv is an array, let me do argv bracket 0, maybe, semicolon, and that's it. Let me now open my terminal window. Let me again do make greet, /greet, and this is going to look a little weird, but here we go, /greet David. You'd think this would now say hello, comma, David, but it says hello, /greet.
Oh, because
All right,
that
so
grid is
wrong
considered
by
as
10.
the argument.
But what can you infer about what is stored in argv0 apparently by convention, by having just poked around here?
1.
The name of the program, which hasn't been useful yet, but if you ever want like to have documentation maybe built into your program, or maybe like an explanation of how to use it, it might be nice to sort of reflexively know what is my name, and you can actually figure out the program's name dynamically. Even if the user renames the file by using mv or right-clicking or control-clicking on it, you can figure out what your name is in argv bracket 0. Well, where is the actual name that was typed in? argv1 is where the actual words begin that the human like me typed in. So let's recompile this. Let's do make greet again, /greet david, and now I think I'll get a proper hello, comma, David. I'm not using get string, I'm not prompting the user, I'm doing it all in one breath. Unfortunately, if in the current moment I forget to provide a name, let's just run /greet, enter, so null. And this is not NUL, this is a different type of null.
That's why
This just means no
it
value.
needs
So this is
the
not very
2.
pretty. Maybe we
That's
can
why it
append
started
against
with
this, and
2.
we can. Let me
Okay.
go ahead and close my terminal window. Let me temporarily get rid of this line of code, and let's conditionally print that greeting out. So if the argument count equals 2, then you know that there's the name of the program, which is always going to be there no
Okay,
matter
we
what,
use a
all
pointer
value
of that
3.
array.
And
Why
another
is that?
word is there, like the name of the
To be
human
honest,
typing the
I
program.
don't know. I'm
Then
not
let's go
comfortable
ahead and,
working with
okay, let's print out hello so-and-so. Else,
pointer,
if
but
the user has not provided their name or they provided too many words, let's just go ahead and give them a default value like hello, comma, world, semicolon. Let me open my terminal window, clear the terminal, make greet again, /greet David still works as before, because the number of arguments in argv is 2, the name of the program and whatever I typed in. But what if I try to be a little more formal? Greet David Malin, enter. It just ignores that, because now the argument count is presumably 3, and we didn't handle that, so I can't even greet people with last names, but that's fine. Similarly, if I just do /greet and no name, that's also not 2, so we again get the default value. But at least now, there's no way this code is going to print out null weirdly, because I'm at least handling and checking how many characters there are.
using command line argument, and it's gonna return 1, and I think he's gonna start with the exit status. But I want to try to do this one, similar to this one. Printf equals to hey, comma, and it's gonna be s rv1. Sorry, that's that. And then if not, it's gonna be does it work? Okay, we don't use this because apparently, so from there, then what we can do is go there. We can do pcc grid, no grid, and then what we can do is do grid is nuts. It is nuts. Hey, that's cool. Nice. The more we know.
Actually is. You can do other things with this too now. If I were to sort of iterate over all of the words typed in, I could do this. For int I is 0, I less than argc, I plus plus. So a relatively simple for loop. I can print out %s comma n and then argv bracket I. So what am I doing here? Well, let's just try. I did that fast, but let's do make greet /greet David Malan. What am I going to see on the screen? Program name, my last name. If I type in more words, so maybe I do David middle initial J Malan, I just get 1 per line. So again, there's really nothing intellectually that interesting going on here. We just have a new integer, conventionally called argc, that tells us how many arguments there are. There is a new array called argv, conventionally. That's just the array of words that were typed in. So we can use last week's techniques with for loops, which are the exact same idea of loops from week 0, to just iterate over these things. So again, the syntax is new. It's going to be hard to remember it. Even I've screwed up multiple times, but it's just going to come with practice. What's important is to understand the ideas underlying this and why these things work, not like where the quotes and square brackets must be, because that will come indeed with practice. All right, so this is actually a fun way to demonstrate this is this. This is not sort of educationally redeeming, but it's fun to show. Let me actually maximize my terminal window. It turns out that there's a lot of programs that come with systems like the operating system we're using called Linux, which is, again, the operating system running in the cloud underneath the hood of VS Code in your terminal window. ASCII art, which is a phrase I've tossed out there a couple times, is like using the characters on your keyboard to depict things, people, places, things, animals, or the like. Well, we can actually use kind of a fun program called Cauce, which, again, is really just for fun, but it does take command line arguments. And just for fun, I thought I'd share these. So if I want to go ahead and run Cauce, let me do Cauce moo.
Did you see Purcell security vulnerability IRC and Next.js? I think I saw it on Twitter, but it's React, right? Not really Next.js only, but it's like the React one, right? Yeah, I think I might need to upgrade the React version of some of the projects, because damn, I'm getting hammered. Okay. You have 4 good numbers of host service to apply temporary mitigation. Okay, so all users should upgrade to the latest patch versions in their release line. Okay, so I think I should probably update my Next.js version or some of the project. Yes, but I've seen it, yeah. If you're on Next Canary, downgrade to the latest stable. If you're using React Router, it's stable. Okay. Redwood SDK, Waku. Okay. Yeah, but I've seen it, and I think I'm gonna update them. Because this is bad, is it? Okay, but yeah, I've heard about it. Thank you for reminding me again.
Enter. And apparently this program's purpose in life is to print a cow using ASCII art and then put the word you type as the command line argument in there. If I change the word to be longer, like moo, enter, the ASCII art sort of adapts. So someone spent like a bunch of hours to figure out how to format this dynamically to make things look nice. They also added some other features whereby with additional command line arguments, it doesn't just have to be a cow saying things, it can be like a duck. So the program is still called Cauce, but if you change the mode to be that of duck and then say something like quack, you'll see 3 command line arguments now. And thus, when I hit enter, now we have a cute little duck quacking. And perhaps especially fun is this, Cauce-f dragon, like roar, enter, and you get this crazy thing that took someone way too long to create. So again, nothing educationally redeeming here other than, hey, kids, here's an example of command line arguments just to do silly things like this. It's a very common technique to more efficiently provide inputs to programs. So there's only one last thing to distill about main, which we've been asking you since last week to take on faith, is why does main return an int? Even though we've not been doing anything with that, we didn't even know what the return values were initially. Well, it turns out that programs can have exit statuses, and we've not seen these visually yet, but even though we've seen programs with side effects, printing out moo or quack or rar on the screen, technically programs can also return sort of secretly numbers, and those numbers.
But yeah, I think don't forget to update your Reacts, guys, because this is bad.
Whether something succeeded or failed. So case in point, if you've been using Zoom sometimes when things are wrong, you might see weird Zoom error message like this, like an error code 1132. That means nothing to the layperson, but odds are there's one or more employees at Zoom that know, oh shoot, they're seeing error code 1132. That is because we wrote code that returns this value in certain situations that indicate failure. This is a little different, but more of us are probably familiar with other numbers in the real world, like 404, whereby you go to a web page where the URL is wrong, the file's been deleted, you're in the wrong place. 404 is similarly a number that to a computer indicates what has gone wrong because some human decided 404 shall mean file not found, for instance. So it's a little different from C code, but same idea. Numbers are used to standardize what can go wrong in programs. So if we look back at C, here is the way we define C main most recently. And we're now taking command line arguments. It turns out, though, that as before, main still and should always be returning an integer, even though we've done nothing with it, even if you don't have command line arguments. So in fact, we can take a step backwards there and consider exactly what this int does for us. Let me go back to VS Code, shrink down my terminal, and close our old example. Let's make one final program here called status.c, because these integers are called status codes, for instance. Let's do this. Include cs50.h, include standardio.h, int main, and I'll stick with void because we're sort of done with command line arguments for now. No, we're not. We will do int main, then int argc, string argv with square brackets. And now let's actually use exit statuses to indicate that something went wrong as opposed to just printing something on the screen. So I'm going to do this. If argc does not equal 2, so I'm inverting the logic now. Instead of equaling 2, if it does not equal 2, let's go ahead and tell the user, yes, missing command line argument, \n. But so that the computer knows that something went wrong too, let's also return any number other than 0 within a certain range. So it turns out that 1 is a good place to start. Otherwise, if all went well, and I can say, in fact, hello, comma, placeholder, and then plug in argv bracket name as before, let's explicitly indicate to the computer that all is well and successful and return 0. And even though this feels a little backwards, like usually 1 is true or yes, and 0 is false or no, turns out that 0 means success by convention, and any positive number, and sometimes negative numbers, means failure. Why is this? Well, if everything's successful, like it's either successful or not. But there are dozens, hundreds, thousands of things, as you know, that can go wrong in computer systems. That's why we're using every number except 0 to describe erroneous situations. So I'm going to keep it simple and use 1 and 0. I could use 1132 to be like Zoom. I could use 404 to be like a browser, but we'll keep it simple because I want to indicate failure or success, respectively. Unfortunately, you don't see this by default. If I do make...
Whoa, there's a...
All right, welcome back. This is CS50 Week 2 sections, and today we're going even deeper into C, talking about arrays, command line arguments, and strings. For those who are here for the first time, my name is Julia, and I am a preceptor here at Harvard. I help run the class here on campus. But as I mentioned, today we're talking all things C, right? Taking even a deeper dive from what we talked about last section, and today that's
There is a section and then there's another one.
CLAs for short.
Okay.
So without further ado, let's dive right in. And first thing we're today is arrays, right? So with another week, we're adding another layer of complexity, right? Another step that we need to take to make our programs run a little better, more efficient. So how use arrays and why use arrays? Well, consider this kind of website, which it might be something that you will implement as a final project in the end of this course. And this was a website implemented by some of the students where they collected some information about how, folks slept last night. For example, how many hours did they sleep last night? How many times they snooze alarm in the morning? So, for example, consider we want to store the number of hours that people slept last night. Well, how could we do that? One option is to just have a bunch of variables, right? So for example, on Monday, I slept for 7 hours. On Tuesday, I slept for 9 hours. And I'm just storing all of these variables randomly in my memory, in my computer, and not really connected together, right? Well, this is where arrays come in. Wouldn't it be nicer to just have everything sort of like continuously together, right? One after another, where, for example, Monday is the first box that we're seeing on the screen, Tuesday is the second box, etc. So,
sorry, let's finish this first.
Enter /status, and then I will not provide a command line argument. I'm just going to go ahead and hit enter, and I'm told missing command line argument, but I don't see a number 1. Similarly, if I run /status and I type in David, I see hello David, but I don't see a status of 0. But there is a way at your keyboard to see what the status code is. And we CS50 will use for automatic grading, for instance, we will look at the status code with which your program executes to determine, oh, was this successful or not? In the real world, when you're automating tests to make sure the industry code works, you might secretly check, is it a 0, is it a 1, is it 1132, is it 404? These status codes are very useful for automation, even though practically speaking, for you and me, they won't be as useful day to day. but you can type this esoteric command, echo $? and see what the exit status was of the most recent command that you ran. So for instance, if I go into my terminal, and again, let's just rerun make status to recompile it, /status, and let's not provide a command line argument. Enter. I see the error, but if I now type this command, echo $? Enter, I should see
1.
because that is what I returned. If by contrast, let's clear this, I rerun /status David, enter, I see hello, comma David. If I echo $? Again, I now see 0. And just to
0.
emphasize the zoom idea, like if I do 1132, that's actually too big to be used here. That would show me 1132, but really it should be a smaller number in the context of these programs. But that indeed is what's going on underneath the hood. So we will very often in programs and problem sets prescribe that what you should have main return this number or this other number in certain cases, so that one, we're sort of doing things the conventional way, and two, we can also automatically detect text is the scrambled version thereof. What's in the middle, the black box this week, is always an algorithm, implemented perhaps in code, but a cipher is the type of function that enciphers information from plain text to ciphertext. So it's just some terms of art here. But the catch with a cipher is that it must rely on a secret. And so there's a secret value, generally known as a key, that is provided to ciphers as a second input. After all, if all of us were using the exact same cipher in the exact same way, we could all decipher or decrypt each other's messages if it all works the same way. But not if we all choose a secret key, like a big random number that only I and the recipient know. Then you guys can use the exact same algorithm, but without my key, you're going to be trying all day long to figure out what my key was, at least so long as we pick a big random enough value. So how does that work? Given the plain text, given a key, we can encipher the information to spit out that ciphertext. So for instance, if the input plain text is high, ! And the key, for the sake of discussion, is super simple and 1, what can we do? Well, the output would be IJ ! If you are using an encryption algorithm known as the Caesar cipher. So back in the day, when the whole world was not really familiar with encryption algorithms yet, because we're talking hundreds of years ago, they didn't have to be that sophisticated, because no one else was thinking to do this. You might as well just add 1 to all of your letters or something like that. So generally, it's believed that Caesar was among those who used rotational or ciphers like this, whereby A becomes B becomes C, or maybe you use bigger numbers and rotate more than one place. It's pretty secure if you're the only one on the planet doing it at that time. Meanwhile, 1 plus high would give us IJ ! Because I plus 1 gives us I, H plus 1 gives us I, and I plus 1 gives us J. And in this scenario, numbers, punctuation just gets passed through unchanged, which is why I leaked the number 50 before, even though this is CS was properly encrypted. Meanwhile, if we want to make things a little more sophisticated, we could use 13. And in fact, a special case of the Caesar cipher with an input of 13 on the internet is called ROT13, R-O-T 13, which just means rotate the letters 13 places. So adding 13 to H and I gives us U and V. If you got too close to the end of the alphabet, you just wrap around from Z to A. And in fact, that's going to be one of the challenges for this coming week's problems, is to figure out if you're encrypting something with the letters of the alphabet that are a little later, how do you indeed wrap around so you get back to A's and B's and C's? Meanwhile, if we do something that's a little more compelling, like you wanted to pass a note to someone in class yesteryear and you're worried about the teacher intercepting it and that message is super sensitive, like I love you, well, you probably want to use something bigger than 1, maybe 13, because a teacher, upon seeing this written on a sheet of paper, probably isn't going to try and probably isn't going to care to decrypt it, but they could, right? If we're only using a relatively small key of 1 or 13 or 14 or 15, they could, if they really cared, just brute force their way through it. And this is actually a technical term, much like in yesteryear, sort of using a battering ram to like brute force your way into a castle door, for instance. Brute force digitally means try 1, try 2, try 3, try 4, ... try all possible keys, and eventually the plain text is going to pop back out if you have enough time. So the world has much fancier encryption algorithms nowadays than this, but we begin by using this as representative of those. The math has, of course, gotten more sophisticated. This is not a good key to use. Right, there's this internet joke for sort of people in the know online and on Reddit, like, oh, ROT 26 is twice as secure as ROT 13. Why is that funny?
It's the same.
Right, it's the same thing, right? A to A, B to B, right? This just literally gives you the same message. So don't believe everything you read, for instance, online. So what about decryption? Well, in the case of the Caesar cipher, it's just the opposite. Instead of adding 1 or adding 13, you subtract 1 or you subtract 13. So for instance, here might be a message a little different from the one with which we began, whereby if we subtract 1 from each of those, we can decrypt this. So for a final flourish here, and for a taste of what lies ahead for problem set 2, what happens if you subtract 1 from U? What do you get? T, and then H, and then I, and then S, and then W, A, S, T, S, and this was CS50. We'll see you next week.
Cool. Okay.
By storing this information into arrays, we're to them, and they're going to be exactly 5 cells that we're the value to 10. Declare a new array of size
Where can I find like the problem, like practice? Is it in the problem set? Collaboration on a problem, blah, blah, look into CSS dev. Okay, can I just not use? I want to try it. Okay, it's probably gonna be okay. Never mind. Run update in your code with terminal. Okay, let's see. Can we use CS50 dev even though I'm not Harvard student? I guess you can. Let's okay, let's try to okay. Run update. Okay, submit Scrabble. What is Scrabble? Whoa. Okay, let's see. Let's try to do this. I think I'm gonna suck at this, but okay. It's okay. So this is the problem. Okay, in the game of Scrabble, players create words to score points. And the number of points is the sum of the point values of each letter in the word. 1, 3, 3, 3, 2, 2, 2, 2, 2, 2. For example, if you wanted to score the word code, you would note that C is worth 3 points and O is worth 1 point and D is, so I think we should, okay. Look at the code. And we get code. In a file called Scrabble C, the program C that determines the winner of a short Scrabble game. You should twice. To input their word and once for player 2 to input their words. Then, depending on which player scores the point most, program should either print wins, player 2 wins, or tie. In the event, okay, so how do we brute force this? To be honest, I kind of forgot a lot of stuff in C, so I did. Okay. Writing some code that you know will compile, of course. The thing is, using the char, because I don't have the, it's gonna be a bit difficult, is it? So we can just do N. I think we're gonna miss scribble.c. Why does it return void, not the return? Notice that you've now included a few headers that will give you access to function and help you. Okay. So we have that. Do we have C type though in here? That's the thing. Like I'm not in the exact environment, you know? Notice that you've not included, okay, some problems in problem sets might contain spoilers, like the next one, that ultimately will walk you through the entire solution. While you are permitted to use code, this is code, okay. So, okay, prompt use for 2 words, okay. Hey, yo, chill, let's not do that. So, okay, prompt user for 2 words. Okay, that's not good. compute score. Okay, this is definitely GitHub Copilot already knows. Print winner. Okay, yeah, this is gonna be a bit difficult. How do we use string? Can we use string? Because the CS50 already provide those stuff, right? It's gonna be a bit harder because we do not have the string type for that. So how can we do this? Can we do this with char? So we can do char word1, yeah, like this. I don't know if 100 is enough or not, but okay. It's gonna be, is it scanf? It's gonna be word1. It's gonna be that as well. Thank you, Copilot. Although, yeah, it's not gonna be as easy, is it? Okay, wait. Array initializer must be what? Okay. I forgot the stuff in here. How do we close? Control N. Shift N. Damn, I really forgot how to close the stuff. Okay, yeah, this is not gonna work. Okay, I'm gonna go for an answer. How can I strings are used for storing text or characters. Unlike many other programming languages, she does not have a string type. To easily create string variables, instead you must be use char type and create an yes, I remember. Okay, but we already made the array. Should we not use that? No? Doesn't work that way? Okay, note that you have to use double quotes. Can I not do this? Array initializer must be an initializer list or string literal. Okay. What does string literal supposed to mean? Okay. What is the error of I see. Okay, errors cannot be assigned this way. Okay. Str copy. Okay, string copy. Okay, what if I want to use scanf? So you can't do this. I mean, of course, you can't. Oh, okay. Probably maximum only like 20. So we can just do that. Okay. So in here we cannot do that. So what we can do is initialize string. So it's gonna be char string. Probably like 20 is enough. And then from there, we can do the similar as the Scrabble problem, which is it's gonna be very, very different, isn't it? It's not gonna be the same, but might work. Then what we can do is print f like player one. Ooh, what is %19s? I see. Okay, what is %19s? Limit input. Ah, okay. Uh to remove the buffer overload. Let's see if this would work. Yeah. So you got to do that, and then I think if we will that work? Because we need to enter the first one. Sorry. So if you run it, it's gonna ask for like the player one, and it's gonna ask for player two. They're gonna keep it first, and then they're gonna tell you whether or not they're a tie or not. So okay. Prompt user compute the score of each word. Okay, how do we do that? Compute score. Okay. Hello, Shais Nuab Kundinya. Okay, hi. I'm trying to reclaim my brain, and I'm just trying to learn the basics again. Like, trying to learn algorithm again. I actually want to start with like week 3 to kind of like relearn a lot of the logic that has been lost due to brain rot and AI. So I kind of really just want to relearn from scratch again, and this just happened to be using C. Okay, so the next one is we create a compute score function. Okay, this is gonna be hard because how we can create compute score q. Okay, this is uses the pointer stuff. It's gonna be a bit difficult because man. Okay, so it's gonna be here. But we can call this up here. So the compiler would know, right? Yes. Now turn the implementation compute score to, okay, so it is correct using that as the, yes, it's basically, I'm basically trying to relearn the algo and data structure and everything from scratch again, so that I could remember, because last time I failed an interview and I couldn't answer a simple question because I forgot. So here I am trying to relearn it so that I wouldn't fail another interview. that how you do array in C? Huh. I forgot. Using square bracket, is it? The thing is, this is gonna be a bit different, right? Since it's using the character, because we don't have strings. So that means from the word, it's going to turn it into, how do we do it? Yeah, that's why I want to re-practice again, because damn, it was horrible. It was such an easy question. I couldn't really do it. And I feel so bad to myself because I was supposed to be able to do it. I don't know why I couldn't do it. Okay, this one confuses me a little bit. Let me try to understand it. It was recursion. Like recursion. Oh my god. Terrible. I feel so terrible. Like I went blank. I was like stood there for like 5 minutes. I feel terrible for myself. I'm like, what the fuck? Why couldn't I answer this? Okay, score is 0, and if we say len equals to string len to word, str len word, let's just say it is right, these nuts, there's 4, so len is gonna be 4, the I is going to be, the loop is gonna repeat it 4 times, if it's upper, and word 1, word I1 is going to be the first, which is D. I know, right? I feel like shit. Like what? You could just put the thing, put the yeah. It's terrible. I don't know, man. I feel like that's like such a shitty moment. I couldn't like the rest of the day. I just lay down in the bed and just like stare at the wall. Like what the fuck? I guess I was way too nervous. It just went blank, and so yeah. But it is what it is. I can only left it off right now. Okay, so word 1 is going to be the first letter, which is in my case would be D, and it's gonna use the is upper, which is gonna convert it to the what do you call it? The it's gonna the uppercase. So it's gonna be D, and then the score, since it's gonna be added by the points array, but we're gonna pick which elements of the points array, which is going to be the word I. The word I is going to be D, in this case D capital. And if we look back at the ASCII table, where is ASCII table? Let's just use this because this it's gonna be 68, 68. So D. It's gonna be the D delta, but we're gonna subtract it with A, and A is 65. So A is 65. So D is gonna be subtracted with A, which is 68 minus 65. It's gonna be 3, and this is gonna grab the point, which is the points, which is the third index, which is going to be 0, 1, 2, and 3, which is gonna be 2. So the score that used to be 0 going to be added by 2. Sorry, it didn't go to the is upper because I used D delta capital. It's going to be the is lower, so it's gonna turn it into is low. Does it matter? It doesn't matter. Yeah. This one is just that, and then it's gonna return another. Yeah, okay, that seems pretty fun. Do I have is upper though? That's the question. For int I. Okay, we do have it, and it's just gonna do this. Okay, this is actually too lower. Okay, so it's either I could use to the too lower. I think it would be the same, right? Thank you, Copilot, for helping me. But let me try to make this on my own. This is actually a much better implementation, no? Because I'm gonna use the n only once, and if its core is into the character. Yeah, A and A. Yeah. Correct. You're correct. But why does it add +1 for this one? Why do Copilot suggest to add 1? Okay, let me try to do the thing here. So let's just use the D's again. Let's just say with D capital. C to lower. If C is above A, because A and okay, because if C is above A and C is a, which is it's just. How's the progress? Any problem? Well, I guess the problem is that the example from the lecture uses the CS50 environment sandbox, I would say, and they have the library and everything set up. They have like the string as type because I forgot that C doesn't have string. It's just use a character but in arrays. So okay, I'm gonna try to follow this Copilot. Okay, I'm probably gonna need to turn it off. I just want to learn. And it's probably gonna return and score correct. Thank you. So I'm not entirely sure if this is would this be the same? Why does we add 1 on the end? What is the ASCII for the lowercase? Lowercase a is 97 and lowercase z is figure of x at 122. So why does we add 1? Shows that the score for the letter A. Okay. I want to try to calculate it manually. Is that okay? Let me try, okay? Let's just say my word is coffee. No, coffee too long. Let's do something short. Let's do cat. C-A-T for word 1. And this third length, the n is going to be 3, correct? So it's going to be 3. Char C. Since all of it, let's just say C with capital C, then it's going to be changed into lower. So it's going to be the C. And since C is 99, C is 99, and C is lower than that, yes, correct, then the score, which used to be 0, is gonna be added by what is the C is 99, subtract by 97, added by 1. Oh shit, I forgot to add the points. Sorry. Sorry. Fuck. I forgot to add the points. And oops. I forgot to add the points. Oh my god. Char string X is usually I do it for a string, but yes, we did. Yeah. Yeah, they have like the get string already, and you can like make the type. So yeah, it's not like this, but I don't know. I kind of want to see if we can just do it in C. I'm just gonna copy the points so that it have this, right? Yes. Okay. Nice. So it's not gonna be this. Oh shit. What did I do? Oh. Sorry, I forgot. Man, I kind of miss and hate C at the same time. So let's do that. So it's not this, but we're gonna do something similar. Score is going to be how would we do this then? Oh, we just do points, right? And we do that. Would that be correct? Wait, let me try. Okay, let me try again. But instead of being added by 1, is it gonna be subtract right now? Okay, let me do the math manually. Okay, since we already know C is 99, since our word is cat, and C is 99, it is over A, which is 97. So it's going to be points, bracket of 99 minus 97, and no need for this then. No need for -1, right? Because that means the points is gonna be 2, and the tooth index is going to be the third, right? Because array, so it's going to be this one. So because this is A, B, C, so it's correct already. No need to add 1, right? Thank you, Anj. Thank you so much. You're welcome. Sorry, thank you, not you're welcome. Like, thank you for joining the stream and giving some pointers. Okay, let me just... Okay, I'm definitely gonna need to fix some of the config here, but let's do that later. Scribble. I guess we just have to run it. I don't know. I haven't really thought about it that far, but it should work, right? Oh, that's cool. That's it? Oh, but it doesn't really this. What if it's not supposed, okay, it's probably gonna be error because I think I forgot to do, how do we make sure that it is word? Do we start line? Is it because we use the start line? Because I'm afraid that we couldn't really check if the character is a character or is it a letter. Because if it's a letter, then it would count. But I remember. No. Okay, it's probably gonna be wrong the first try. So let's see. GCC scribble. Probably gonna be wrong. Ah, shit. Sorry, wrong argument. Okay. Cat. 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 Dog. I don't think this is working. Is it working? I don't think this is working. Wait. Because if it's okay, let me try. Okay. Let's do AAA and BBB. If it's okay, if it's AAA, let's try it. Yeah, if it's AAA, it's gonna be 1 + 1 + 1. If it's BBB, it's gonna be 3 + 3 + 3. Okay, so let's just do AAA. This is BBB. B should win. Okay, that's actually correct. Wait, what? Let's do question. Let's do this. Okay. Question. It's a tie. Is it a tie? Sorry. Let's do red. 32 wins. Okay, it's actually, is it working? I'm not entirely sure. Like, how do I know if it's working? Yeah, we cannot do the test, right? Okay. How to do a simple, let's do, okay, I have the script. How can I make I guess this works. I'm not sure. Like, okay, that works. I'm gonna do the problem set later. I think I'm just gonna finish on the Scrabble because let's do Scrabble and winner and see if it's working as well. Let's do computer and then science. It should be player 2. Okay, this is, oh no, it's player 1. Okay. Player 1 is Scrabble. Player 1 wins. Okay, I think that's working, right? Okay, that's fantastic. Awesome. I think I'm gonna try to do the other problem set later. And yeah, but I guess that's it. Wow, this is very nice. Thank you, Alfie, for the recommendation. Definitely gonna be okay. I know from here we would be using Python and SQL and Shiva says you have and Flask. But I think I'm gonna be more focusing on this, and probably after that I'm gonna try to continue deepening JavaScript and TypeScript. So I think that's at least the plan for next. You know what? I haven't really had like a good place where I could like write content or something like that, like a Kanban board to show. Maybe I should make some sort of like a Notion Kanban board or something like that for the stream on like what is it, what ideas do I have, what projects that I want to do. Maybe we can do that. I don't know if I still have manual page or not. We can do a page called streaming plan, I guess, and then we can create some sort of like a Kanban content planner. I don't know, maybe we have. You know what? I'm just gonna do it simply because I don't know. Can board, yes. There we go. Okay. Stream ideas. So I think we can write. How can we edit this? I forgot. It's been a while. I haven't used Notion in a while. So I think. Can we not change this? Can we edit it? Yes. Okay. Oh, it's just a different type of group. I'll probably make something up later. Oh, that's interesting. Is there like a project section that's here? Projects. Maybe we could just do all of this. Like, yeah, this is pretty nice. Like, I mean, getting back to HTML and everything as well. Good idea. We can add that to here. So let's do not page, but can do that. And I think tomorrow I kind of want to do. Is there a way to edit this? Okay, yeah, I just do all of this, right? And then I think the next one, okay, so we could try that, and I think we can try the CS50, oops, week 3. Algorithm. We can do that maybe tomorrow or something. Okay, fine, 1 second. Intermediate. Ah, this is fun. Oh, this is gonna be fun. But I think I wanna learn like the DOM manipulation of JavaScript at first. So let's do that. Let's write it down. Because I kind of forgot how to do it manually without like using React and stuff. So that's actually a good plan. Thank you. Check some calculation. The week 2 less comfortable one. What do you mean? Is it this one? We have this we have string compare, bro. Ah, okay. It's less than okay. Let's go. This one? Is it? What do you mean? Oh, less comfortable. Is it this what you're talking about? Less comfortable? Wow, this looks really good. What is in this script? Ah, okay. Okay, yeah, I'm definitely gonna need to redo some JavaScript stuff. Ah, okay. Where is it? Where can I find like the example pro? Is it this one? Is it this one? I don't see the project. Is it final project? Is there like another site? I it's okay. So I already went here. I went to problem set, and then it's only this one. Problem set, right? This one, right? Maybe readability?
Let's take a look at readability. In readability, your task is going to be to write a program in C that can take some text and assess the approximate reading level of that text. So for example, you might run your program as /readability. Your program should then prompt the user to type in some text, and after the user...
Oh, in week 1? Okay. Okay, this cannot be reached. This one, right? Yeah, okay. What is this? To be honest, it's just I want to learn the basics, like the algorithm and stuff like that. But when I saw like the lecture for like week 2, that it starts talks about memories, talks about arrays and stuff like that, I started like, oh, okay, you know what? It's fine. I guess it's been a while since I really dig down to the basics. Like all this time, all I'm doing is just making stuff with a bunch of abstraction, and I don't really think too much. And I think it's because of the AI. So I think I kind of, let's do it from the start again. So let's do it from the beginning again. So yeah, I'd really love to try to do it again. Cool. Let's visit People Solution. Election program. Damn, okay. That is interesting. You know what? Maybe we should start from the beginning to make this, I think it would be fun. Like starting from scratch again. Whoa. Okay, nice. But okay, I guess let's just keep it in the Notion ideas first. So I think we're gonna try to do week 3, and I think probably week 4. What is week memory? Okay, segmentation faults, stack heap buffer. I guess it's fine. Yeah, let's do it one by one this time. Because I might do the other projects that I'm doing, right? So we'll see how that goes. Okay, Okay, I guess that's it for tonight. Hope everyone have a great day. Math for computer science and DSA Geeks for Geeks. Yeah, Geeks for Geeks is okay. It's just that sometimes a lot of the stuff is, yeah, it's okay. What is this? Damn, okay. This is a lot of things to do, but yeah. Oh, that is interesting. That is fun. Not fun. Oh, this is gonna be interesting. Okay, this one I'm gonna need to be starting to learn a little bit of C. Thank goodness, like JavaScript takes a lot of the C syntax, so it's not that different. But again, I guess that's it for tonight. It's getting tired. It's getting late. I'm gonna sleep. Hope everyone have a great day, night, evening, or whatever time zone that you are in. I'll see you guys again tomorrow, or in 2 days, or in 3 days, or any other day next week. So yeah. Hope everyone have a great day, or night, or morning. And oh, okay, they have a lot of stuff. Okay. Damn, they have all the social medias, right? Okay, so sorry, never mind. Okay, I'll see you guys tomorrow or in other days. Bye bye. And I joined the Discord because Alfie is making it amazing.